In our slide, CORBA have been there for a while before SOAP-based protocol were introduced in 1999. The problem with CORBA was that the protocol they used was binary and relied on various machine-dependent interpretation, unlike XML, which is interpreted the same way regardless of the machine. CORBA is gradually phasing out due to interoperability problem on the web, but the industry have learned a lot from that experience. REST approach was introduced by Roy Fielding in his PhD thesis, where he stated that the service endpoints can be web URI acting as web methods, and the data exchanges may be done using XML. This approach, however, ties all SOA realization as hosted on the web using HTTP. Finally, web services uses a general approach of SOA, stating that SOA is not related to a particular hosting environment like the web. It introduces various standards to ensure that SOA is interoperable in all implementations perspective. This led to quite a bit of complexity of understanding web services and all its WS standard. As you know, there are a lot of WS star standard we call WS standards. Both as more and more, but as more and more of these standards are now managed by the tools, web services are also now going mainstream again. This discussion of heterogeneous SOA will apply to both web services and REST. We will not focus on CORBA as this technology is gradually phasing out and no longer of much interest to new or existing projects. Now I'll move on to the next slide. Slide number 4. Interoperability is an important requirement in SOA. Let's look at what issues are related to interoperability. The term interoperability mean that consumer A on the left, which is this one, left, which may as well be a web service consuming service provided by B, can successfully consume the service if the following issues are resolved. Both A and B communicate using a common protocol. Both A and B recognize each other's data type. The number of bits represented by data are known. Both use same endianness. That means that if A is big endian, then B is also big endian. If A is little endian, B is also little endian. Both use the same character set, so it can be ASCII, Unicode, and EBCDIC. So if we can manage all of these, then we make our service truly interoperable and homogeneous over various platforms. I will go over with each of these in more detail shortly. Excuse me, I have to do some thing here because all right, let's move on to the next slide. Slide number 5. XML is the most common data format used by present implementation of SOA, but by web service and REST also. As far as consumers of web services and REST is concerned, they all see XML formatted documents. XML tend to be very verbose easily due to its text nature, but it's a price to pay to achieve true interoperability among various environments. Use of XML format just not only make it truly interoperable, but also allows it to reuse existing technology resources. XML data could be passed through HTTP and firewall. Therefore, SOAP protocol, which is XML-based, use in web services can be used through HTTP. The verbosity of XML led to various other XML compression and optimization standards known as MTOM. We will not discuss that in this webinar. XML processing is somewhat lengthy due to the fact that the parsing is tag-based and each tag is interpreted differently. On the other hand, binary formats quickly reads into a formatted data structure. Therefore, XML have to be always parsed, and no privilege is there to load XML directly into data structure in memory, unlike a binary format which actually reads directly into a data structure. But now know that even after using this plain XML text formatted document, we still may have heterogeneous problem. And the problem we may face even after using XML, we are going to see a number of slides next to see what problems are there even if we use truly interoperable web services. So we'll now move on to slide number 6. To achieve true independence across services, loose coupling among services is a necessity. Two systems are loosely coupled when the expected behavior of a service does not change before and after its use and does not affect other consumers. So you can see there is a consumer and there is a web service, and if the consumer consumes the service, it should not affect the service of other consumer that is instantiating the service also. Services are assumed stateless on their first call by a consumer if the subsequent call make it behave differently than the service is stateful. In service-oriented architecture, we may have both stateful and stateless services. If the service is stateful, then the client manages the state of the service. Next slide, slide number 7. This is a case where the service is not loosely coupled, and you can see that there are 3 consumers here. Each have their own instance here. There are 3 instances you can notice here, and consumer 1 instantiates the service on the servers, and the proxies manage the instance and binds the state to consumer 1. If the consumer 1 processes information using that service may affect consumer 2 and consumer 3, and when that happens, it's not loosely coupled, it's tightly coupled. If the consumer 1 is instantiating the service and consumer 2 and 3 does not have any knowledge of consumer 1 is even exists, then we are talking about loosely coupled services here. A loosely coupled service is the one in which each of these instances are totally independent, have no relationship with even inter-instance communication, and also there is no relationship to which consumer consumed the service. And let's move on to slide number 7. This slide shows that a true web service is independent of protocol, transport protocol. Most of the time, transport protocol used by web services are HTTP, but GMS is also very popular within an organization. And many organizations uses GMS to send messages, service SOAP messages from inter-organization, within inter-organization. That means that within the organization, they are using GMS messaging, and outside the organization, which is like a client outside the organizations, are like general third parties or ordinary consumers. All of them consume the service using HTTP. So as you can see here in this slide, there are GMS, HTTP, and also services may be operational over SMTP, FTP, and other protocol standards. So a web service must ensure that all of these standards are maintained while the service is consumed. This in this slide explains a very short overview of what SOAP messages are. SOAP is a XML document with a header and body part. And both of these body parts are XML as well. The header contains routing specific information, and body contain data-specific information. Most of the time, the header is related to the data. So if the data is related to WS security, then the header should have WS security header. So header and body is not totally disjoint. They are actually related. A SOAP message is a simple XML document purely in ASCII format, and may have binary format as well. There are binary XMLs out there, and there are binary standards like MTOM, which I discussed previously. This SOAP message is transferred through any messages that actually runs over service. In this slide, WSDL is a service description language in web services. WSDL is related to web services only. REST does not have any such service descriptors, but some projects use WADL, Web Application Description Language, but there is no such standard for interoperability, so it is strictly an implementation choice whether to use WADL or not. There used to be three kinds of WSDL, but presently only document literal is used. Document literal can have both wrapped or unwrapped formats, so it can be wrapped or unwrapped. RPC literal is not being used. RPC encoded is obsolete. RPC literal is not very popular. If you are developing web services using RPC literal, you will face heterogeneity problem, because most of the clients out there are designed for document literal format, and if you are exposing your services using RPC literal, most possibly that your service will have difficult time consumption. Presently, all web services should follow document literal format. There used to be three kinds of WSDL. Right now, just your focus should be only document literal. Slide number 11. We are now getting closer to heterogeneity problem. The heterogeneity problem arises when there are server component and client component, and there is a network in between, and that's where the problem begins, because WS interoperability ensure that it doesn't matter what protocol somebody is using and what programming languages somebody is using, and that's why we use SOAP protocol, to make sure that everything passes through the same common format. Still using that, how is it possible to have heterogeneity problem? The problem arises, as I spoke, that because of bit boundary, endianness, and all those things, which I will discuss in the next slides. Heterogeneity problem occur when it comes to programming languages and the implementation platform. Before diving into various heterogeneity issues, let's look into some programming languages used for web services, server side and the client side. Java programming language is one of the most popular programming languages used when it comes to web services development. C#.NET competes with Java directly and also implement many WS star standard. When it comes to service implementation, Java, C#, and C++. So that Java, C#, and C++ are the three most common programming languages used today. Web services run on servers, preferably a JMS for Java, HTTP for other, including Java protocol is used. Therefore, the service must be deployed on a server, possibly an ESB. Java web services are deployed in Java application server and ESB. C# web services are deployed in IIS server, and C++ web services are deployed using Apache module, or they may have independent C++ HTTP server as well. For Java, there are plenty of options to build web services, starting from JAX RPC, JAX WS, Spring, etc. To many open source like solution as well, like Apache Axis and other Apache projects like Tomcat and Geronimo may be used for application server. JBoss is also popular for, and Glassfish is also popular as an ESB for Java applications. These ESB contain JMS servers, so JMS may be used with web services. OpenESB is also one of the popular ESB. Using Java for web services would be the most inexpensive and possibly the easiest path to go for building standards-based web services. C# is an extremely popular language, and it presently competes so much with Java that there are now .NET runtime that run inside Linux and Mac OS X. In fact, I have tried that. I've tried the Mono project, in which you can download it to Mono project, go to the Mono project and download various CLR for Linux and Mac OS X and various other environment, which actually runs .NET executable. On the server side, we see we may have some restriction on programming languages, but on the client side, there are no restriction on what programming language could be used. So a client is free to choose what programming languages can be used. Servers were restricted, but the client have no restriction on programming languages. Each programming language have their own proxy generation tool from WSDL. As you can see here, that the proxies are generated from WSDL, which is the reason why we say that WSDL is a static document and should be deprecated with caution. Versioning of WSDL is important. So what we see here is WSDL. So all these clients sees WSDL and generate proxies from that WSDL in order to consume the service. So now let's move on to something interesting now, which actually is leading to what really are the problem with interoperability. Even if we use SOAP messages, even we use very, very high quality service development, but still there may be some interoperability issues. One of the main issues I'm going to discuss now is, in this slide, you have XML data type. XML data type have two main types, the primitive and complex types. Within primitive type, I will focus on types that WSDL documents support. These are spatial types, which is composed of any type, which is this, QName, URI. So this leads to the spatial types. And then on the logical type, we only have the Boolean. On the numeric types, we have a number of things: a byte, short, integer, long, float, double, and decimal. These all falls into the numeric type, XML data type mapping. On the string type, we only have character type. On the date type, we have date time type. And on the other side, the complex side, complex data type have three parts, which is the array type goes to the array. Derived types are structures, and the binary type goes to the binary data representation, which is usually. Now you can see on the right side, which is the most important part, is this part. On the right side, the green ones you see here are the ones that is safe. If you are using, your web service is using green data type that is green, marked as green here, are the safe type. If your web service is using some of the yellow type one, then there may be some interoperability issues. If your service is using these red ones, then there are definitely some interoperability issues. So let's see what these issues are. Now in this slide, I've taken the red ones, red ones with the yellow ones, and the red text one. So the red text. There was a red text on the previous slide. Now let's look at the circles here. These circles represent number of bits represented by each type. The byte is 8, everybody knows that. Short is 16, knows that, most of the people. Integers are 32-bit, long is 64-bit, double is 10 byte, and decimal have no knowledge of how many bytes it can be. It's runtime. Structures are runtime too. So structure depends on what kind of complex data type somebody is building. Decimal is based on how many decimal places somebody puts after the decimal point. If the decimal point is there's just one digit, then it may be considered as float or even integer. Now, again, let's focus on the green types. In the green types, we have, these are green type, but these are unsigned. The unsigned part is not always safe because Java programming languages itself does not support unsigned numbers. So if your service is providing unsigned data type as exposed through web services, then you may face some interoperability issues with Java, because Java does not have unsigned numbers. So if you're using unsigned short or unsigned byte, unsigned integer, unsigned long, all of these will have some interoperability issues with Java programming languages. Now, how can we, if you all have already developed it, how can we avoid that? Well, let's focus on this slide. It's a little bit further. Here I have focused only on the types that were not green. The signed kind have some special problem related to some programming languages, for example, Java. Double precision and decimal formats are not always supported by small client platform like embedded processor. Double precision is not always a requirement in embedded systems or small processors. When adding double precision libraries in embedded systems, it adds a huge amount of program memory into the solution, which makes the solution expensive. And that's why if the service out there is using double precision to take or receive or return these double precision values or decimal values, then embedded systems that are designed to operate only integers and floating point will not be able to consume your service. For these embedded processors to consume your double precision services, they have to be redesigned, recompiled with double precision libraries in it so that they can consume the service. And most likely, most people will not do that. So if your service is using double precision, do not use double precision if you really want your service to be totally interoperable and heterogeneous and true service-oriented architecture, which can be consumed by anything, just about anything. And the complex type is safe if the data represented by the complex type is one of the green types, which I explained in the previous slide. If the complex type happen to use one of these other types, then this complex type can be unsafe, especially when they use these yellow ones and the red ones. Note that the integer and long types are marked yellow because yellow is a 32-bit and long is 64-bit. And most of the time in a small processor, some of the processor used by even mobile phone does not have a 64-bit computation. 64-bit is something that is usually on a high-end processor. If you are using Java virtual machine for embedded processor, like embedded phone, embedded mobile phone, then what will happen is that there is a Java virtual machine that will actually create 64-bit simulation in it. So most of the JVM have a 64-bit simulation in it. But in embedded systems, if your service is relied or called and designed to be called from embedded devices, very small, for example, things like credit card processing machine or on-site sale devices like, for example, many cash registers. All of these have a very small processor, very tiny, very inexpensive processor that's not able to handle 64-bit. And most of these applications are written in C. And the C definitely does not have processing power to handle 64-bit. Additional libraries may be created to actually support 64-bit, but most of the time it's an additional effort. Also, 32-bit as an integer type is not very common in embedded processors. Embedded processors are mostly 16-bit still. And when we say there is an integer exposed as a service from a web service, that means that the value can be 32-bit, and if it's consumed by an embedded processor which represents 16-bit as an integer, then there will be loss of data if the size of the data exceed 16-bit that is returned from the web service. So if you are dealing with integers and the data you think that will never exceed 16-bit in value, use short. Do not use integer, because as soon as you use integer, you will be facing some heterogeneity issues when exposed and consumed by small devices like embedded devices and cell phones. Now let's move on to the next slide, slide number 14. Again, I got some. All right. Slide number 14. So this summarizes which I just discussed a few minutes ago. Platform does not support the data type or bit length. Now let's summarize. The client platform may not have support for the data type or length. Like we said, 64-bit long format is usually not supported in most C and C++ compilers. If no programmatic support for 64-bit long is provided, then the large values that exceed 32-bit integer, the service will behave incorrectly. Offering unsigned data type is not recommended on an exposed web service. Usually this matter could be easily managed by moving to a higher data type. For example, instead of using unsigned short kind, use integer kind. If using unsigned type is really needed, then the proxies must be able to generate and handle this kind of types correctly without any bit error. In some digital signal processors, when the accumulator overflows, the value saturates. Unlike traditional processor, when there is an overflow, the overflow bit is turned on within a processor and the remainder of the overflow reside in the accumulator. But in a DSP, in a saturation mode, when there is an overflow, the DSP accumulator freezes to the maximum possible value that can be represented by that accumulator while still enabling the overflow bit. So a DSP, digital signal processor, I know about DSP because I worked for Texas Instruments for a long time, and I know how internally DSP works. And that's why I'm saying that if you are developing a service, develop a service that works from every possible environment, even including digital signal processors. So in a digital signal processor, consuming a web service, for example, a signal processing web service that actually does some signal processing for the web, for the signal processor. For example, speech recognition can be one of the signal processing service that can be offered, and that may be consumed by a digital signal processor. Make sure that this heterogeneity issues are managed on the service level. Complex types can be composed of many other types, but as long as the complex type does not have one of those yellow or red marked types, then it's safe and there is no requirement for additional precaution for your web services to be totally interoperable and heterogeneous. Now, slide number 15. This slide shows you how services are bound. Once there is a web WSDL, a service exposes a web service exposes a WSDL. And this WSDL is fetched by a proxy generator, which actually builds the proxies for the client. And then in this case, A is the client. Once the proxies are built, it becomes part of A. And A will communicate with B using the proxy. And because these proxies are extremely important things, because it's the proxy level at which time, at which point you have to deal with the heterogeneity issues. If there are unsigned values, if there are overflows, underflows, this kind of saturation thing, everything have to be managed in the proxy level, because this proxy is a copy of the web service. It's a proxy of the web service on the client side. The third approach is to generate SOAP message. Now, there is a third approach. The first approach is the proxy. The second approach is the tie and stub generation, which is usually done by the server. But the third approach is to generate the SOAP message at runtime. And we will not discuss about that one because that is usually used by BPL engine. BPL engine uses the third method. All of these have something to do with messaging and proxies, regardless of what method is being used. We are finally dealing with pure binary data that has been converted from XML type to native type. When the proxies on the client side, when the output of the proxies are pure binary data, and the client sees the binary data eventually. It gets the binary data eventually, whatever intermediate representation it was. Intermediate representation we used was XML, but eventually it converts to binary data when it comes to actually operating on the data when the services are concerned. In this slide, use local objects, and this is showing you how to create a service and bind it to local object types. So local object to native type mapping. When native binary types are used, that usually map to XML types, as we showed in the past few slides when we discussed about safe and unsafe data type. As you can see here, that the XML data type is first converted. XML data type is first converted to local object. So it's converted from here to local object. Local object is platform specific and also programming language specific. So this is both platform specific and also programming language specific. This is the object which the core implementation understands, because the core implementation takes a binary object and operates on that. The flow also goes in reverse. So this core implementation is based on core logic, and this actually follows the other reverse route. It's the same thing. From the local object, we generate XML data, which represent independent object, independent local implementation, independent format in XML. Assuming that the local object representation is correctly handling the data type, we still have a few things to consider in order to build a true heterogeneous SOA. Let's see what those are. Slide number 17. In this slide, endianness is discussed. Endianness is related to how byte sequences are stored in memory to represent binary data. For example, a 32-bit integer would need 4 bytes to represent the value. But memory is organized as bytes, and each address represents a byte address. But this is the reason that we say that my PC have 1 megabytes of memory. Due to this reason, there is 2 ways. There are 2 ways to store data in memory to represent a data type. One is the little endian, which stores the lower byte, order byte to the lower order memory and higher order byte to higher memory. The other format is the natural format called the big endian format, in which higher order byte is stored in the lower order memory address. The big endian format makes memory debugging easy because of ease of locating the data as it appears, similar to the data type that is being used. The big endian format and the data itself look the same. On the little endian, you see it's reversed. So when you have a memory debugger and you want to see the memory, you have to make sure that you look them in reverse order when the platform is little endian. If the big endian, you do not have to really do anything because you can just look at the memory and see what the data is there. The good thing is that when it comes to primitive data type, the process will deal with the proper endianness and we do not need to worry about it. But when it comes to base 64 binary format, the endianness become important. If the byte array represented by binary format represent an array of short integer, long integer, or some other values that is binary, then the endianness must be known. In addition, the binary data carries this source endianness, that means the programming language with which the service was written. So if the service was written using Java, then the value returned by the service is a big endian because Java is big endian. And if it's written in C++, then the endianness depends on the processor. So let's say this example. If I have a C++ web service that is running on a PowerPC, and PowerPC is big endian. So when we deploy this C++ service on a PowerPC, like for example IBM's Power Series, then it's operating correctly because the data returned by the data types are all big endian, and the client we are using are also big endian, for example Java client or C++ client. As soon as we port that C++ web service to a Windows platform, it becomes little endian and the service no longer works because the clients are expecting big endian format. The service is returning little endian for Windows. So just writing a service will not make your service totally heterogeneous. You have to provide the API for each of the services to make sure that the service can handle both little endian and big endian. So how can we solve this problem? Let's see. Resolving Endinness problem. Nope. Let's see. The first thing is that the client must be informed about the endianness of the binary data. The client must also know its own endianness. If the two endianness don't match, then endian conversion is required. The endianness may be processor specific, as used by C and C++ compiler, because C and C++ compilers are running on operating system, and whatever the operating system endianness is going to be what the C and C++ compilers endianness. On the other hand, Java is always big endian regardless of the processor or the operating system. The JVM translates the little endian format if the operating system or the processor supports that into big endian format by the JVM. So Java behaved the same way on both PowerPC and Intel processors. On the other hand, DSPs like Texas Instruments 64X DSP support both big endian and little endian. Even if the processor is implemented in either endian format, the OS may stick to a single endianness. An example of this is a Symbian OS, which is designed for mobile platform. Most of the Nokia phone have Symbian OS in it. And Symbian OS is designed on little endian format regardless of the processor. If the processor is big endian, the Symbian OS converts everything to little endian format. And any C compiler that is based on Symbian OS automatically becomes little endian. So if the service is exposed as Java Web Services and is consumed by Symbian OS, then the problem arises because Java Web Services are returning binary data in big endian format, and the Symbian OS, which runs on most Nokia phone, will receive the binary data as little endian format. So the proxies have to deal with that, convert the big endian format into little endian format. Now all of this endianness problem are only on binary data. For example, when you are transferring files, binary files, speech programs, video data, all of these binary data are based on integer values that are platform specific and endian specific, what I would say. And when your service is based on specific endianness, the client must be informed about what endianness and how to parse that binary data. At the service level, the service should stick to its own endianness as long as binary data is concerned. The service designer does not have to worry about if the service is implemented in Java or other programming languages. Notice that if this data returned by the service is big endian, but the client is based on little endian, this adds additional conversion step. A good service designer may have binary data returned in either big or endian service. So if you are building services, make sure that you have an option for the client to choose the endianness. If you're returning binary data from your service, allow the client to choose the endianness. That's one big solution to this. Slide number 19. As it may appear that strings are immune to interoperability issues, strings are not immune to interoperability issues. But surprisingly, string may be subject to quite a bit of interoperability, non-interoperability, what I would say. Strings are represented by processor and OS specific. Sometimes runtime engine, for example, JVM and Common Language Runtime, CLR, as used in .NET, Unicode is represented. But Unicode is represented in many formats. There are UTF-8 format, UTF-16 format, and when it comes to UTF format, if it's not a byte format, like for example, UTF-16 format, we now face the endianness problem again. Now ASCII is one of the common standard used by 7-bit code, and ASCII never faces any problem because ASCII strings are always 8-bit, and 8 bits does not, the endianness does not apply to 8-bit data. IBM mainframes are EBCDIC. EBCDIC is another encoding standard other than ASCII, which IBM uses throughout all its mainframes from the 60s. Let's say that a service returns string represented in ASCII, which is consumed by IBM mainframe. So what happens? The generated proxy is not aware of the data format. When a proxy is generated, the proxy does not know what kind of strings the service is going to return. And that's why there is no additional processing within the proxy itself. Unless it is Java, the string will remain intelligible. For example, if the return data, the string, return string is in ASCII format, there is no need to do anything. If the return data is UTF-8 format, then the client must understand what UTF-8 format is. If the return string type is UTF-16 format, then the client must be able to process UTF-16 as at the same time deal with the endianness problem, because the strings now represent 16-bit characters. 16-bit characters mean there are 2 bytes, and because there are 2 bytes, we have endianness issue. Similarly, if a service is hosted on an IBM mainframe, it is not desirable to return a string with episodic character. If an IBM mainframe is returning episodic character set, nobody will be able to consume that service because nobody knows how to deal with episodic character sets. So IBM mainframe service should convert everything to some known format like UTF-8 format. UTF-8 format is a Unicode code format compatible, 100% compatible with ASCII format. And using UTF-8 format to return strings from your web service is the best possible solution that will be interoperable throughout just about any devices. Now, you can see that simply returning a string is not a good idea, because simply returning a string from your web service will return a string either in ASCII format or episodic format or Unicode format, but you have to ensure that all your strings are returned in Unicode, preferably UTF-8 format. So I will UTF-8 format is what you want to return your string with, and when you're dealing with web services. Same thing when your web service takes an argument, a string argument, make sure that that string argument understands the UTF-8 format. We are slide number 20 now. Security issues. Security issues are one of the issues that people faces when it comes to key agreement. Symmetric key is used by many services, but most of the service uses a symmetric key. Symmetric key is based on public key architecture, and passing that public key is one of the problems that faced on many public key architecture. How can you transfer that public key to the client? The client have to get the public key to communicate with the service. If the asymmetric and public key architecture is not available, then use transport layer security, which is HTTPS, if the client can support it. If the client does not have the horsepower to use public key architecture, and which is the common case for many small platform devices, then use symmetric key architecture. And symmetric key is very fast algorithm. Usually the AES algorithm is extremely fast and is very easily implementable on embedded systems. Digitally assign these data, the SOAP message using WS security with symmetric key algorithm. And you will notice that in our next slide, I will explain this more graphically to what is happening on the key agreement thing. In this slide, there is a service that can handle 3 things. It can handle WS security with a symmetric key algorithm. It can handle HTTPS, and it can also handle symmetric key. So if you are building a very, very interoperable and heterogeneous service, and you want all the services consumers to consume this service, make sure that you offer all 3 of these. Each service, if the client, for example, this embedded system client, does not have support for WS security asymmetric and transport layer security, which is HTTPS. So what it does is just use a symmetric key algorithm to get the security information, securely consume the web services. Now how does it get the key, the secret key. The secret key may be provided by the service once the client is logged in. Every client has to log into the service to consume a service, and after logging in, the service may provide the client with a secret key, and each time the client logs in, each time it gets a different secret key, and this makes the service consumption extremely secure. So that's covers the security issues, and we are going to cover memory issues and processing power issues, and then wrap up our webinar and go into question and answer session. The memory and processing power of a client is usually very limited in some cases. For example, embedded systems and mobile processors, mobile phones. And that's why when you are building services, make sure that you do not return data that is very large in size. Allow the client to request the required data sizes. So let's move on to the next slide, in which we will see what kind of control you want to have in your service for the client to inform you the size of the data it needs. In this case, the service have features which the client can use. For example, setting up timeout. If the internet speed is slow, the client may set the timeout, increase the timeout. Chunk size is the size of the data per unit. Here is an example. When there is a database query, it returns a set of rows from the database table. Each row may be thought as the unit of the information, and the chunk is the 10 rows that is returned by the database query. Now the database query may have 1,000 rows. The response the client wants is only 10 rows, the first 10 rows. Because this client have limited in memory, it wants 10 rows at a time. It will fetch 10 rows, and then so this client will process that 10 rows, and then it will request the next 10 rows. So this is called chunking. Each time the client requests this chunk of the next set, and this has to be handled by the service, and the service should be chunkable. Cache size, most of the time you'll notice the client doesn't have enough memory or enough hard disk space. And in that case, the service should provide some cache space for the client itself. The client, because it cannot store the information inside its own memory space, or doesn't have enough resources to save the RAM, and also inside RAM, and also the client can get disconnected. If the client gets disconnected, then you have to do all the processing again and get the memory and fetching again. In that case, the client may be provided with some caching area which the client may store inside the cache just in case it gets disconnected or it doesn't have enough memory. So it can compute and use this cache for its processing. So that is the chunking part. And let's move on. Sometimes the screen gets locked for some reason. I don't understand why it's happening. That's why you see that I'm trying to expose. Now, shipping API is because of this heterogeneity problem that I discussed in this short seminar. It is a good idea that you build these APIs, the client APIs, and provide them to the client. If you're building web services, then you should also build a client for the web service for each independent platform, including C, C++, Java, and .NET. Each of these have their own interoperability issues, Endinness problem, and different problems, which the client will not understand, the consumer, the third-party business will not understand, and will not probably have the time to do all this research into Endinness issues and bit boundary issues that we have already discussed. It is a good idea to do all this client solutions, API in the form of API, and provide this API for the customer. And also sometimes it's a good idea to provide the source code when it comes to embedded systems, for example, C source code or C++ source code, because most of the time embedded systems uses their own embedded development tools, and most of the embedded tools require optimization and also code changes internally. So that's why I would suggest that to provide all the API within the solution, with the solution. Now we're almost at the end of this seminar. Here I'm showing that what SOALIB provides. The SOALIB is a very highly interoperable heterogeneous service which actually provides all the things that I have discussed in this webinar. It makes sure that endianness, data type issues, conversion, everything is handled. And we also provide all these C API, C++ API, Java API. So once somebody uses all this API, they don't have to worry about any endianness or anything. Actually, they don't have to face any problem or think about this solution as long as heterogeneous and true SOA is concerned. Again, the screen locked, sorry. And this is a sample example. And in the next slide, last slide, is the example of what SOALIB can do. As you can see, that SOALIB is now running on embedded systems, which is an x86 based Atom processor. It's an Atom chip. And embedded devices and third-party SOA services, third-party application and mobile systems, everything can intercommunicate with each other. And so these are highly diverse, disparate systems. And you can see that using the approach I showed you, building SOA services with no interoperability problem, and also addressing the heterogeneity issues that I discussed. You can have a system like this where you have a central server which can manage any kind of communication from various disparate systems out there, regardless of processing and other related platform-specific information. So that concludes our webinar, and I'd like to thank you for your participation in this. I hopefully was able to dive into some detail of heterogeneity. If you have any questions, you maybe feel free to ask me. Let me know if you have any questions. We have about we are a little bit over time, 5 minutes over. If you have no question right now, and if you have any question after the webinar is over, when you are working with your services, send your question to us and send us an email using this address, soalib@soalib.com, and then I will be able to answer that question for you if you have any questions. Thank you for attending this webinar, and look forward to seeing you another webinar coming on the 30th of this month, and there is going to be more webinars coming in July, which I will also present. Thank you, and goodbye.